What's up, 7th graders? It's Mrs. Talati.
And Mrs. Cervantes.
And together we are
Mrs. Cervati.
Today's the last section of your module 14. It's 14.3 and it's ordering real numbers. So you guys are going to see how we're going to take the rational numbers and the irrational numbers. We're going to simplify their expressions and then compare them as far as greater than or least than. Greater than or least than, is that how you say it? Least than or greater than?
Less than.
Yeah, less than. And then order them on a number line. So just to review the difference between an irrational and a rational number. And I'm going to start with rational because it's our first one. Remember, a rational number is any number that you can write in a fraction form, right? So it's a over b, where b cannot equal 0, right? So if we talk about these kind of numbers, we can talk about whole numbers. And if we have something like 2 would be, I don't want to write a dash, we'll write 2 is 2 over 1. If we have an integer, something like -7, we can write -7 over 1. If we have a fraction, it can be a regular fraction, an improper fraction, or a mixed number. All fall under the category of a fraction. And then when we talk about decimals, actually I have 2 more categories. Decimals would be any decimal that repeats or terminates. Now the last one that we have to add to our list of rational numbers is all perfect square roots. Remember, in my class we talk about all the ones you can count on your hand. So it'd be like 1, 4, 9, 16, 25, just to name the first 5, right? So all perfect square roots, because they're a whole number, when you take them out of the root symbol, you can write those as a fraction. Which means then our irrational numbers are, this is where you gotta pay attention. They involve pi, but you could see it written as 2 pi. You could see it written as pi divided by 2. You could see it written as pi plus 2. Anytime you see an expression or an equation that involves pi, it automatically puts it into the irrational category because that decimal doesn't terminate or repeat. And then all non-perfect square roots, so remember all the ones that fit in between our perfects. So in between 1 and 4, we have the square root of 2, the square root of 3. In between 4 and 9, we have the square root of 5, square root of 6, dot, dot, dot. So any square root that is not perfect then falls into the irrational category. You want to add anything?
Yeah, so I want to clarify. So my class, I said it a little bit differently in class today. We talked about irrational numbers being non-perfect squares, and then we even said, we wrote on our notes that it was also any decimal that didn't end or didn't repeat. So doesn't end and doesn't repeat. So then if you listen to the way Ms. Talati is describing that, what she's really telling you, and I don't know if you guys, my class picked up on it in the last video, was that, and I never mentioned it in class, is that every non-perfect square ends up being a decimal that never ends and never repeats. So any non-perfect square is your decimal that never ends and never repeats. Any decimal that ends or repeats falls into your other categories down in rational numbers.
Yep.
Okay? All right, let's look at comparing values, comparing expressions.
And we're telling you right now, if you just throw in a greater than or less than sign with no justification or no rationality you're thinking, you are automatically wrong.
Okay, so square root of 3 plus 5 is compared to 3 plus the square root of 5. And then don't just guess, because this is bigger, the 5, that one's going to be bigger. Don't just guess on these, because you're adding 3 to this one, but you're adding 5 to that. So if we're looking at square root of 3, we know that's a non-perfect square. So we're going to estimate the square root of 3. And I don't know, did you show what the 2 numbers? Did you go through that whole thing? Okay. So what 2 perfect squares is 3 in between? So it would be in between the perfect square of 1 and the perfect square of 4. And then like we talked about in class, 3 is closer to 4. So the square root of 1 ends up being 1. The square root of 4 is 2. So it's closer to 2. You may have to do some of these out to check them out. So if it's closer there, it's either 1.1, 1.2, all the way to 1.9. So if you want to get to as close to 4 as you can, you might do 1.9 times 1.9. So 9 times 9 is 81. 9 times 1 is 9, plus 8 is 17. And then add your 0, 9, 1, add them down. Oops, I'm writing on my other part, so I'll come down here. 9 and 7 is 16. So, and then 2 decimal places. So 3.61, that's about as close as we're going to get. If we wanted to get closer, remember, you would go out. If you want to get closer and closer and more accurate, you would go out decimal places with this, but we're only going to go to the tenth, so we're going to call it 1.9. So the square root of 3 is 1.9. If I add 1.9 plus 5, I get 6.9. Okay? And then if I'm comparing to the square root of 5 plus 3, so let's do this. Here's my answer here. Square root of 5, I'll come over here. Again, a non-perfect square, so estimate the two perfect squares it's between. So 4 and 9. And it's closer to 4, so then again, you're going to test it out. You might do 4.1 times 4.1. Do your multiplication. Add. My writing's all over the place. 2 decimal places. So 16.81, that's wrong. What did I just do?
Oh, square root of 4 is 2, not 4. It should be 2.1 times 2.1.
Oh, that's what I did. Sorry.
Not the indicator, you did it right though.
See how fast I was going? But do you see how my number was off and I knew I was way off? So 1, 2, 0, 2, 4. So 4.41.
Yeah.
So that's as close as we get. So 4.41. You could go 4.2 and see if you get closer. So 4.41 plus 3 gives me a 7.41. And if I'm comparing 6.9 and 7.41, I know that square root of 3 plus 5 is less than 3 plus square root of 5. Okay?
You guys just saw how much work was involved.
Yeah,
with
and
that
you see how
comparison.
fast I started going, and what's the first thing I did? I forgot to square root this, and then I started multiplying by 4.1. So be careful.
That was all clear, that was all great.
Oh, but I'm in the way.
I know, okay.
I'm
Go
in
ahead,
your
clear it,
way.
Just clear it. I cheat. I just love her handwriting, you guys should know that by now. All right, so now that is what you guys compare. Now the next part is if we have to order from least to greatest. Pay attention to this first. I'm gonna start out, it does not always go smallest to biggest. So what I'm gonna do is I'm gonna put all these numbers. So I have my square root of 22, my pi plus 1, and my 4.5 in decimal form, okay? My square root of 22, I'm going to do exactly what Cervanta just did. The perfect square below is 16. Perfect square above is 25. That means it's going to be between 4 and 5. I am, 6 away here, and I'm 3 away here. So I know it's going to be closer. So I'm going to go with 4.7. 9, 4, 28, 32, 0, 8, 2, 18. Please make sure my math is correct because I am going rather fast. We got 22.09. So we can say it's approximately, and remember that one's not super far over. So I would be okay right there with saying that it's a plus or minus 4.7. 4.6 would work as well. Anytime we have pi, we refer to it as 3.14. If I'm going to add 1, I now have a 4.14. So this one is going to be a 4.14, and I hope that at this point in the game, all of our 7-8 students know that 4.5 is 4.5. Now here's where you guys got to pay attention. If we're putting them in order from least to greatest, we convert them into our decimal form so that we can compare them. But when we actually answer the question, we want to put them back in their original form. So if I look at my 3 decimals, I have a 4.7, a 4.14, and a 4.5. So I am going to go, you know what I just realized everyone says?
What?
Is that we're going to have, and I'm going to catch it before they're going to say this, but watch this. So if I go pi plus 1, my next one would be 4.5, and then my last one would be the root of 22, right?
Yeah.
So check this out. If we say that the square root of 22 is plus or minus 4.7,
Yeah.
couldn't they technically say that the square root of 22 could be less than 4.14?
Ooh.
So should we make a rule right now that if we're ordering, we're only going to
Comparing
take
and ordering, we're only looking at the
positives?
positives. Yeah.
Do we?
Uh-huh.
Okay. So did you guys hear that? So when we're looking at square roots, even though it's got a plus or minus value, when we're ordering them, we want to identify it as the positive version.
Yes.
Okay, so again, I want to repeat. We convert them into decimals to compare, but then we put them in their original form to list them in order from least to greatest.
Yeah. Did we not notice that before?
I don't think so.
All right, let's look at this. 4 people have found the distance in kilometers across a canyon using different methods. Is that the end of it?
Yeah.
Their results are given in the table. Order the distance from greatest to least. So again, you're doing greatest to least this time. All right, so I'm going to do Wana. So Wana, I want to change these all to be in the same form. You've got a square root, you have a fraction, you have a repeating decimal, and you have a mixed number. So you want to put, the last two are a little bit easier to do than the first two. So I'd like to put these all in the same form. So we're going to go decimal form. So I'll do square root 28. And look at that first, 28 is not a perfect square. What two perfect squares is that in between 25 and 36? And I won't skip this step this time. Square root of 25 is 5. Square root of 36 is 6. And 28 is closer to 5. So I might try, like, what do you want to try, Miss Talati? 5.2 or 5.3?
I think 5.2.
5.2, 5.2 times 5.2. This is where we're really going to see if you guys are struggling with your multiplication like I just did. Okay, 10 carry 26 and 27, two decimal places, right? 27.04. That's pretty close. So I'm going to say that 5.2 works. If you wanted to go a little bit more out, we could do 5.25, or do you want to mess with that and show them accuracy or no? Okay. All right, so we're going to say about...
You guys can thank me later.
5.2, yep, she's nice. Okay. All right.
Okay, so then I'm going to look at our ratio, right? We have 23 over 4, which means we're going to divide. 23 goes on the inside. Divided by 4, I'm going to add a decimal and 3 zeros, just to get the routine. 4 goes into 2, 0. We go into 5, we got a 20. Bring down, we got a 7, 28. Look at that there. We have a terminating decimal, and we have a 5.75. And then, like Cervantes said earlier, our next one is a repeating 5.5, and then our very last one is going to be a 5.5. Now, what I'm going to do is I'm going to add a 0 here, just to kind of help with the comparison, and then I'm going to add a 5.5 here. Because I know that some of you guys might get to the point where you don't know how to compare those. So this problem is asking us from greatest to least, which means our biggest one in the original form is, Cervantes?
Ooh, 23 over 4.
23 over 4.
Do not write 5.75.
Yes.
Those are just to help you guys.
What's the next one?
5.5 repeating.
Perfect.
Then 5.5, mixed number.
Perfect.
And square root 28 or root 28.
And that, and you guys, you just saw in the last example it said least to greatest, and this example says greatest to least, so please don't fall into that trap. All right, and you have 4 problems, but quite a bit of work. I recommend you guys do this work underneath your tab because these should be cut and glued in your note taker book. Sorry,
yes, they're still not.
No, it's
some people still don't have them cut and taped in. I have mine taped.
They want to spend lunch with me, that's what it is.
Yeah.
So let's go like this. Where are you going to spend your lunch if you don't cut and glue your note takers in? Put that. Let's put it in your questions. Say, do I really want to spend lunch with Mrs. Talati or Mrs. Cervantes?
Yes.
Have a good day.